Welcome to stage 3, the moment this course stops being abstract and becomes something you can actually hold in your hands. We're opening a desktop case and taking a guided tour of the 7 or 8 components living inside. PSU at the bottom, motherboard front and center, CPU hiding under its cooler, RAM standing tall in vertical slots, GPU stretched horizontally across a PCIe slot. By the end of this lesson, a PC won't boot ticket stops being a mystery and starts being a physical problem you can diagnose by sight. Let's start at the bottom of the case with the power supply. The PSU. Wall power comes in, gets converted into the 12, 5, and 3.3 volt rails every component depends on. 4 things to lock in. Size the wattage to your load. Roughly 450 watts for office, 750 for gaming, 1,000 plus for workstations with a 1.3x safety multiplier. Look for an 80 plus rating. Gold is the sweet spot. Choose modular cables when you can for cleaner airflow. And if you smell burnt capacitor or hear popping, replace it. Never repair a PSU because when it fails, it can take other components down with it. Move the camera up from the PSU and you hit the motherboard, the big flat board everything else plugs into. 4 things decide if a board is right for your build. Form factor. ATX is full size, MATX is the Office PC standard, Mini ITX is for compact builds, and the case has to match. Socket has to match the CPU exactly. LGA 1851 for current Intel, AM5 for current Ryzen. Wrong socket means the chip literally won't drop in. Chipset is the feature tier on that socket. Z790 and X670 are enthusiast, M60 and B650 are mainstream value. And at a glance, a standard ATX gives you 1 CPU socket, 4 RAM slots, a 16-lane PCIe for the GPU, and 2 to 3 NVMe slots. Now pull the side panel off and step back. Every desktop you'll ever open has the same 7 components in roughly the same spots. PSU at the bottom, motherboard filling the center, CPU and cooler up top, RAM standing vertical to the right of the CPU, GPU lying horizontal in the PCIe slot, M2 drives flat on the board, and 2.5-inch storage tucked into the bays. Layouts vary, roles don't. Once you know this map, no case looks unfamiliar again. Move the camera up to the top of the board. That's the CPU, the brain doing every calculation and pulling anywhere from 65 to 250 watts that turns almost entirely into heat. 2 things matter when you're working on one. The socket has to match. Intel LGA 1851 or AMD AM5 get it wrong, and the chip physically won't drop in. And you always need a pea-sized blob of thermal paste in the center to bridge the micro gaps between chip and cooler. For the cooler itself, a heatsink and fan handles most office machines silently up to 200 watts. AIO liquid takes over for gaming rigs and 200 watt plus chips. Just know the pump becomes a failure point around year 5. Pan down from the CPU and you'll spot 3 more parts, each with its own keyed slot so you literally can't mix them up. RAM clips into the tall vertical DIMM slots beside the CPU. Install in matched pairs to get dual channel speed, so 2 16s beats a single 32. The GPU drops into the biggest horizontal slot, PCIe times 16, and on modern cards, it's so heavy you'll want a sag bracket plus 1 to 3 power cables from the PSU. Storage splits 2 ways. M2 NVMe sticks lay flat right on the board, no cables, pushing 7 to 14 gigabytes a second. SATA drives sit in the case bays with a ribbon and a power lead, slower and cheaper, and honestly on the way out. Now let's put it all together with 4 real help desk tickets. Ticket 1, dead PC, no lights. Start with the PSU. That's almost always the culprit. Then suspect the motherboard. Ticket 2, powers on, dies in 30 seconds. Classic overheat. Open the case and check that CPU fan is actually spinning. Ticket 3, no signal. 9 times out of 10, the cable's plugged into the motherboard port instead of the GPU below it. And ticket 4, random blue screens, boot mem test, and check the RAM stick by stick. Same case, 4 different parts, 4 confident fixes. Before we close out, lock in the language. These 12 abbreviations are what you'll see on every spec sheet, every ticket, every component box. PSU, motherboard, CPU, GPU, RAM, DIMM, ATX, socket, chipset, PCC, M2, and TDP. You don't need to memorize data sheets, just know what each three-letter chunk points to inside the case. Once these click, a colleague saying, "The LGA 1851 socket on a B760 board sounds like placed English instead of alphabet soup." Now that the vocabulary clicks, let's clear out the myths that send beginners down the wrong path. More watts doesn't mean a better power supply. A 1,000-watt unit in an office PC just wastes money and runs less efficiently. RAM is not universal. DDR4 won't even fit a DDR5 slot. A GPU fits any X16 slot, but only the top one usually gives you full lanes. Liquid cooling isn't automatically better than a good air cooler. And thermal paste, application matters more than brand. Memorize these and you'll save real customers real money. And that's lesson 18 in the bag. 7 components, 1 open desktop case, and a whole new vocabulary you can actually point at. Remember the 4 anchors. Size the PSU to the load, the motherboard is the backbone, heat is the CPU's enemy, and the slot type tells you what fits. Next up, lesson 19, we close the lid and tackle laptops. What's soldered, what's socketed, and what you can realistically upgrade. Stage 3 rolls on. See you there.